So chapter 5, we are on string, list, and files, and then we are on part 2, starting from encryption and then list and file. And we cover string and list already, so it pretty much would be the encryption and then files, okay? So before we get started, let's look at what is really the encryption. So encryption is the process of encoding the information for the purpose of keeping it secret and transmit privately. Okay, so there are a lot of different purpose or reasons that why we need encryption. So basically, there is a sender in the communication system. We have a sender, and then we have a receiver. All right, so this is a sender-receiver model. Okay. So basically, between the sender and receiver, we can say if this guy send ABC and this guy want to receive ABC, and we can send the plain text of the ABC over, right? That's one way. Another way is that, okay, I can make a little adjustment. So basically, I'm sorry, this one should be ABC. I actually write it wrong. So this should be ABC. Instead of sending the ABC, I can send B, C, D, and then receiver side also receive B, C, D, and then I convert back to ABC. Okay, that's another way. So this one actually is encryption.
Oh, for like codes, kind of.
Yeah. Or sometimes we call it in cipher. CIPHER, in cipher. Sometimes we call it encryptor or encryption or in cipher, and this one is called decipher. Or sometimes we call decryptor or decryption. Okay. So basically, we are talking about this, and then actually this is very, very important in communication right now. It is not one single layer. No, it's no longer a single layer. There may be multiple layers, 3 layer, 4 layer of encryption. And then actually it can be a multiple layer of encryption, or basically it may be packaged. It may be packaged in several levels. So let's look at let's go to Google, okay? So for communication, basically, we have a 7-layer architecture for doing networking, okay? So each layer, from application, presentation, session layer, transport layer, network layer, data layer, to physical layer, each layer, your original data may be just, your original data may be just certain data over there. Original, your data just this black part. And then because of communication purpose, we actually would put multiple layer of information up to there to make it bigger. And at each level, we transmit from here to here. We take out the data link layer data, and then we actually try to decipher it. Okay, so basically in 7 layer, you actually add up more layers of the frame, and then make the data longer, and then make it in script, so make it safer to transmit the data. Okay, but basically, say if I have a browser, the browser actually is a application program, right? And then inside the browser, you may have something called Adobe Player, right? Adobe. That's a presentation, and then under Adobe, you may have the HTTP, and then there's a transport network layer. It's called TCP/IP layer, and then there's a MAC address. That's data link layer. So this is the so-called 7-layer architecture that you actually need to transmit data from the source side to the destination side. Okay, and there are tons of related topics to cover this. So that's not what we want to see right here. So what we want to see right here is just to teach you very simple encryptor and descriptor. Okay, so basically you will be in a environment like this. So you can have a public key, private key environment. So basically, key is a encryptor key. So basically, I have this Roy has a plain message, and then we use the public key to increase the data, and then we transmit the data, and then Rick decrypt it, and then convert it back to the plain text. Okay, and then from Rick to transmit the data to Roy, you can use the Roy's public key, and then Roy will use its private key to decode it. So this is a system. So basically, there's a RSA algorithm, reverse Shamir Edelman algorithm, that actually will help you to encode the data. This is a public key transmit system, but this one is way too difficult for you to understand right now, so we don't actually look at it. So now let's look at a simple encryptor and decryptor. The simplest one, let me open my file. So last week we have this chapter 1. Okay, let me open this one. This one finished. Let me close this one. So I have this one, chapter 5. So here, let's get started. The first encryptor we will look at is a very simple encryptor. It's called Kaiser, Caesar's Kaiser encryptor. That's the simplest one, and very simple one. Usually people use that for encryptor scheme. So basically, you can do -1, this is -3 scheme. So F equal -3 to C, E equal -3 to B, and D equal -3 to A, okay? So this kind of encryptor, so let's get started with this one. So let's do this one called Caesar, okay? Caesar encryptor. So basically, I have the original message. Okay, so my original message will be okay. Let's attempt Egypt. Okay, say if I have a message from the general, say let's attack Egypt, right? And I'm going to encrypt it. So actually here I should print now. Okay, I have my original message like this. Now I'm going to do encoded message, right? And my encoded message would be calling the encryptor, and then I put my original message into there, right? Now I need to define my encryptor. Okay, so I receive my original message, right? So let's call it just M, okay? Make things easier. Okay, just call it M, okay? So I receive a message called M, and then from I say, let me actually do this. Let me do a string that is actually an empty string, okay? And then for I in range length of M. So basically I started from I equals 0 to I equals length of M minus 1, but not including M, okay? Not including the length of M.
So
So go through every character for the n. Is that okay?
Yeah, so length makes it subtract the number. So like m is 9, so it does 1 to 8.
Yeah, something like that. But let's do this. Okay. Right now, actually, I have encryptor, and here I should pass in a key as well. Okay. So let's assume that this key right now is 1. Okay. That's actually 1. I have passed a key over. So now actually I traverse through my whole string, right? So basically, I have my character. My character should be my message. My strings are i's character. I assign to character, right? So I have my ASCII code that would be the ORD of CH, right? This one is actually getting the character. Right? And then I find my ORD. Right? So before we do that, actually do anything, let's do this. If character is actually, the character actually is greater equal to A, right? And the character is less than equal to capital Z. That is actually, so this one actually, I should say, is lower. So I should say is lower. Okay, let me check, okay? Let me check, okay? Let me check the Python's is lower function. So I check Python's is lowercase function. It's called is lower, okay? So this one should be is lower. If the character is a lowercase, right? If that is a lowercase, then actually my A will plus equals my key, right? And then my A, let me see. Okay, I'm sorry. I would have a A1. Let me see. My character will minus the lowercase a. Let me see. I'm sorry. This one should be my A should minus my ORD of A. So let's call this one as X instead of using A. Okay, let's call this one as X. So my character ASCII code will actually minus the ASCII code A, so that actually would be a number between 0 and 25, right? And I would need to plus with my key, okay? And then take modular by 26. And then this whole thing will plus order of A, and then the whole thing, and then this whole thing will convert back to character. And then my string will attach that character in. Okay? So that one actually complete the encoder scheme. So basically, I have a character, and if that character is a lowercase character, I will actually use the ASCII code of that character minus A's character. So this ASCII code minus A's character will be a number between 0 to 25. And then I plus 1 in this case And the total result would be from 1 to 26. And 10 modular by 26, you become 0 to 25. So if I have a B, say, if I have a B, B minus A will become 1. 1 plus T will be 2. 2 10 modular by 26 will become 2. So 2 plus A, that will become what? That will become C. So that will actually will attach a C to my S. Is that okay so far? Is that okay so far?
It's a bit
a little bit too hard?
No, it's not too hard. It's just
too abstract.
It's like a little confusing where you start getting into the like.
Let me actually try one more time, okay? Let's do this. Okay, so I start from I have a message, right? So say my message actually right now, if my message only have a BA X, okay, for example. So I get my length of my M. So M's length actually is 3, right? So initially I get my M0. So this one is M0. I get this M0 assigned to a character called CH, right? So this is a character. That actually is a B. So my B actually I find its ASCII codes with ORD. So that actually should be 98, right? So my 98 minus the ASCII code of A, that's 97, I should get 1. So my 1 plus the key now is E1. So actually plus 1, the key become 2. Key plus the X minus A would be 2. And then 10 modular by 26 is still 2. And 2 plus A's ASCII code will be plus 97, that become 99. And 99 will map to character C. Okay, so detail, you can forget it. Just like my ASCII code of B will be increased by 1 and then will be assigned to my S. So basically, you will perform B will be converted to C, A will convert it to B, okay, lowercase, okay, and then Z will become Y will be converted to Z, and Z will be converted back to A because you take 26, 10 modular by 26. Is that okay?
I think so. Yeah.
So basically, if you get a Z, let's look at Z's case. If I have a Z over here, Z's ASCII code mass is the obstacle is 25. 25 plus 1 will be 26. 26 10 modular by 26 will be 0. 0 plus A will become A, so actually you will convert it to A. Okay? So if not lowercase, then what will happen? And if it is uppercase. Okay, uppercase, I just copy over, doing the same thing. And then you said that I actually changed to A. That's the second case for uppercase. Third case is none of these. None of these, I would just directly append the CH in there. Okay, directly append the character in there. Other than that, I will just return my S. Okay, and after the equation, I would print out my encoded message. Okay, and I'll run. Okay, that's a tag. It should become something like this, right? It's encrypted, right? Now yeah. I'm going to decrypt it.
Wait, so when you say like, so let's so the L
will be capital L, right? So you go to here. Minus A, L maybe L, J, K, 10, 11, 12. It should be 12.
12 and
minus A should be 11. 11 plus 1 will be 12. 12, 10 multiplied by 26. You go to 12. 12 plus A, you go back to N. LM, you go become M. So L become M. E become F. T become U. So one character, follow it. Is that okay?
Yeah.
If you check it, it's actually one letter follow it. So that's actually a line, okay? That's actually give me a alignment. So you see clearly. L become M, E become F, T become U, S become T. Is that okay?
Yeah.
So now I want to do decrypt. I got a secret message and I want to decrypt. Right? Instead of encrypting it, I'm going to solve it. Okay? So here I'm trying to solve it. So here is plus key. And then here I would just decrease key. Okay, originally I plus it in here, but now I'm trying to just.
So there's no key.
So it will be even out. Right? So basically I'm just copying this whole thing over. Okay. And I just pass here. And here I say this one's decrypt. And this one's decoded. Right? And this one I should be sending in encoded message. Right? Same key. I have the same key.
Yeah.
So this one, instead of using 1, let me call it a key X. Okay? Key X, some secret code X. And then here I define my key X equals 1. Okay? Is that okay so far?
Key X equals 1.
Yeah. So actually I use 1 as my key.
How does that work again?
That key will be passed to here, passed to my encrypt, and it will add 1 to there. If my key become 2, you will have a distance of 2.
Wait, isn't the key and the key X different?
It's the same.
Oh, okay.
It's the same.
Okay.
Is encryptor is plus 1, decryptor will minus 1 back. So you move from 1 to 2, now move from 2 to back to 1. Is that okay? So my original code is A, I go to B when I encrypt, then I go back to A. So this one's plus 1, this one's minus 1. If my original A go to C, C go back to A, this one's plus 2, this here is minus 2. Is that okay? So here actually is what? Here actually I send my key in there, right? It's a plus key, and here I have a minus key. Now recover it back. Okay, so L to M, M back to L. So now if my key X I assign, say 4, I assign a key distance of 4. So my L, M, N, O, P. P is L plus 4. L, M, N, O, P, right? And then P go back to L.
Oh, so the when you define the encrypt, that's just telling it to move over.
How many
letters?
Yeah. Is that okay?
Yeah.
Okay. So this one actually is an encryptor and decryptor. Okay, so this one's a simple Caesar encryptor decryptor. Okay, it actually do encryption and decryption. And then if I want to get in a file, okay, I want to read a file, not just the data. So here, let's do this. Okay, let's do this. I actually keep the same thing over here, right? And here, instead of doing this, okay, what I'll do is like, here I have a file f in equals open a.txt, right? For R for reading, right? And then my original message will be fin.read. Okay, I read the whole thing into a message. Okay. And then I here actually I read in and I get the encoded data. Then here I have f out equals open b.text, and this one for writing. Okay, I encrypt the data and then I actually write it out. So I have f out dot write. I put my encode message in there and I write to the file called b.text. Okay, after that, this one I finish, so I say f in dot close. Okay, I read the file in and then I close the file. I write the file out and then I close the file.
Wait.
Okay.
Open
the file.
yeah.
Okay. And then next one I do f in2 within the second time. I open my B file, this time for reading, right? And I decode it. Actually, I read in, so I have my encode MSG will be, let me do 2, okay? This one is encoded message 2. My encoded message 2 will be f in2 dot read. Okay, and then I decode it. After I read in, I decode it. Actually, after that, my f in2 got closed. Okay, then I have a f out2 that equals open c.text r, and then my f out2 that write out data of the C file. So write out the decode message. And then my f out2 closed. Okay. So this one is the previous one. I just used the sentence from my own program. Let's attack Egypt, right? This one's different. I from my original side. So here is my original side. Right? From my original side, I actually read a file. Right? And then encrypt it. Right? And then after I encrypt it, I write to a file called B, and B got emailed to somewhere else, right? And the other guy from the remote side, so here is a remote side. So the remote side get the email from somebody else, and then open that file and read it. After read it, you use the decryption, and then print out a decoded message. Okay, and then you write that message back to a file called c.text. So right here, let's create a file called a.text, right? And then here, let's try to have some secret. What sort of the secret message we have here? I'm sorry, it's actually. Let's try something like, I don't know. Okay, let's try this one. Okay, let's try this one. Declaration of Independence. Okay. So here, I'm not sure what this is, but in Congress, whatever. Okay, let's copy the whole thing. Okay, copy the whole thing. Put it over here. No matter what it is, I don't know, I don't care. In Congress, when the codes or whatever, okay, so this one, no matter what it say, that actually does save all. Okay, so there is a 8.txt. And here I have my file. Okay, I'll read the 8.txt in, and then I'm going to encode it, and then I'm going to send it out as email, and then I'll decode it, and then write back to C file. So let's do this one. Is that okay?
Yeah, I have a question.
Yes, go ahead.
What is, so you c.text and then comma R. What does the R mean?
R is reading.
So.
Oh, so this one actually should be writing. It should write out, yes. The last one actually write out to a file. After decode, you want to save the message.
Okay. So so it'll go to, it'll send you the.
Okay, so after finish, right? I run it, right? I run the whole thing. My beta test is something like this. It got encrypted, right? It got encrypted. It's okay, nobody knows what's going on, right?
Yeah.
And then the other guy received it, recovered it in C file. Is that okay?
Okay.
That's the way we operate Caesar's encryptor and decryptor. And the previous one has no file involved. And this one we have file involved. So file is also very important. You can handle file to read in something or write out something is also very important. Is that okay?
Yeah.
So now the next one is I'm going to talk about how to read file data from file in, or how to actually write data to file. So here, let me actually create another file. It's called d.txt, okay? And this one, let's just try A, B, C, D, E, F, G. Okay, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have A, B, C, D, E. I have 1, 2, 3, 4, 5. Okay, something like this. I have my D file. So now I'm going to talk about the file operations. The first one is to read in the whole file. So the first one is read in the whole file. Okay, read in the whole file is I have already actually demonstrated is that I put my dx, okay, and then a reading format, and then I have my string that is f.read, and then print out my string s, and then f file closed. Okay, so basically this one is I open the file called d.x, and then each time I read in the whole file, put it into a string. So this string is actually a whole file. Okay, so you read in the whole file and then print it out. as a string, right? That's number one, read the whole file. Second one is read line by line reading. Okay, read line by line. So basically, same thing, I have my f equals open for reading. And then what I do is a line equals, let me say lines, okay, equals f dot read lines. Okay, so you will read in the whole file into number of lines. So let's do this. For I in range of length of lines, then print lines, the ith line. So after reader, I can close the file anyway. Let me actually close at the end, okay? Even though I can close it early. So this one read in the whole file. To a list of string, and each string representing one line. And this string representing one line. It's a list of string. So I print this out. Or you can also do this. If you don't like this one, you can also do this one. You can also do, don't put this, I just print out lines. And here for line, each one I read in a line from lines. And I just print out line. That's also fine. Either way, it's okay.
Then what does the for line and lines mean? What does the lines and lines mean?
Lines and line is line S is actually many lines.
Yeah.
A line is a single line string.
So so it's one at a time, kind of.
Yeah. This one is traversed by index, and this one is traversed through list. Okay. So actually, I read the whole file into a list of lines, and each time I get a line using index to access a line from my lines. And this one actually, lines is a list, right? It's a list, and then I read one line from lines, and print it out. Okay, let's look at what's the difference over here. Okay, so basically traverse through index, I read in the whole number of lines, and then it actually will print out each of the line like that. Okay, is that okay?
So skip a line, right?
Skip the line. Skip what line?
No, I mean
Where does it skip? There is no skip of lines.
No, because like there's A to Z, and then there is usually right underneath, isn't it?
Where?
When it's like
like this?
Yeah.
Because of print line will print the extra line mark over it. And I strip out the original baseless and out. Okay, so this is okay like this. Is that okay? This one is actually reading in the whole file into number of lines. But because each line it will end with the baseless n, so I take that baseless out. But when you print line, print, it will actually put another new \n in there. So that's why we see separated by a line. So I take that extra line out and then print to change the line. So this one is read line, and the previous one is read all. It read the whole thing into a string, and then this one is read lines. Okay, so the next one, this one is read lines. I'm sorry, this name I should. I'm sorry, this one I should close. Instead of changing here, I should actually go to my here. I have a naming problem here. This one. So this one, let me do here. I have the read line. So this one actually is not read line. It actually should be read line plus s, multiple line. Okay, I read a multiple line into a. I read a multiple line into a lines. Okay, the next one is read line. The next side is really read line. Okay, this read line is different from the previous read lines. So again, I have the f equals open d.text, and I'm reading it. Okay, same thing, but here I actually have the line equals f dot read line, no s. You read in the line and then while line, okay, then I print my line dot strip, okay, and then line equals f dot read line. After I print out the line, I continue to read a line in, and at the end, I close my file. This one, I read line by line, and then until the line is empty, then I will not do it. Otherwise, I read the line, take out the extra \n and print out with a new \n. So that one should actually also print out line by line, but actually this one's read in line by line. Okay. And then the next one is a read character. Okay, this one's the same thing. I have my file open and then say d.txt. I read in this file, and then I have a character, right? And then I have f.read. And instead of putting nothing, I put 1. That is a single character. If you put nothing, it will be infinity. So while my character has something, I print out, let me see, if my character not equals \n, right? I'll print out my character ending with nothing. You connect everything together. Else, that would be a print line. I just do print, right? After that, I read in a new character. So this one, each time you read a character, and then after that, I close my file. Okay, so I read a character. Okay, check that character if that is empty or not. If it is not a change your line, I print the character and without changing line. And if it actually is a \n, then I print to clean a new, open a new line. Okay, after that, I read in a new character. If the character exists, I do this again. Until I read a character and that is actually empty, then I will close my file. Let's do it. You still print out the same thing. So all of these print out the same thing. Instead of the reading scheme is like reading a character, reading a single line. This one reading a single line. This one reading the whole file into a list of lines. And the last one, the read all, is reading the whole file into a single string. So which one is the best way? I don't know. It depends on how you actually read it. It depends on how you actually read it.
So these are all the different ways to
different way to read data from d.text into the file.
Yeah, okay. To get stuff from a different
Yeah.
Okay.
So right here say, I finished my reading, right? So I open a file called e.txt. This one I have for this one is for writing, right? Then I'm trying to write, and then at the end I need to close my G file anyway. That's okay. Then here I read in number of lines, so I would use this, right? I'll use this. Okay, and then I get off the line, and then I say my G.write. I put in my lines in there. Is that okay? Then I'll write all the line into the lines into the E file. So let's run. Okay, and then I have my E file open. It's like this. Is that okay? Is that okay? So now my read all I can also write and write all. So G equals open. Again, my d.txt, and this time it's write file. Okay, and I have my S already, right? So actually, this one before my actually here I should do what? I should do my G.write and put in my S, right? So this one shouldn't be D. Let me call it F, okay? Because I don't want to repeat that. So G.closed, and then I open that F file for writing, and I have the whole file read in as a string, and now I write out the whole string. And actually I have my F file. Where's my F file? Wait, where's my F file? F.txt for writing. I have my E, where's my F? Wait, let me save all, okay? So let me do this one, read all. Okay, so there's a F file, print now, okay? So I have read all, write all, I have read lines, write lines, right? Now let's do read line without S, okay? And write line without S, okay? So this one again, I have my G file equals open. So that one is fg text, okay? This one is for writing. Again, let me copy this whole thing over. This is similar structure. So here is not reading, right? It actually should be, I'm sorry, this one actually is a little bit more tricky. This open file, you cannot finish it, right? Because each time you read in a line. So what you should do is actually here, I need to cut this one over here. When I actually realign, I print it, right? At the same time, I should do G.write, and then with that line, right? I write out that line, and at the end, my F closed and my G should also be closed. So each line I read in a line, and then I write out that line to G.text, right? And that's it. Here you have the else. That's okay. That's okay. Let's do. So this one is the read line. It will actually write line as well, and there's a G.text. Okay, still the same. Okay. Then I have my read character, right? I have my character. Same thing here. You cannot actually separate the operation for read and write. So actually here, I read in the character, then I write out a character one by one. So here I have my G and H.text. Okay, this one for writing. Okay, so I read in the character if it whatever, it actually I don't care. My G.write I just write out the character. The rest of them doesn't change. And then I close my G file. And then this one is run. Okay, there's a H file. Still the same. Is that okay so far? So in the I told you the encryption, decryption, and over here, I also teach you read the whole file, write the whole file out, read the lines in, write the lines in, read single line and write out directly, read in a single line, write out directly, read in a single line, write out directly. Now the next one, read in the character, write out the character directly, read in the character, write out the character directly. Is that okay? These are the file and shape because here we actually discuss this chapter is on string list and file, and we have the encoder decoder already. So let's go through these different slices, okay, to see what I did not cover so far.
Oh.
Yes, question?
So when it says open the file,
yes,
then what's the reason of closing it?
What is the reason of closing it? Otherwise, your file keep open.
Oh, so
So
it just takes it out to copy it?
What?
Do you just take it out to copy it?
You just take it out so that the file won't be written. So whenever you open the file at the end of the program or somewhere in the program, you need to close it to be safe. You don't want the file keep open and then somebody just write it from internet or somewhere.
Oh, okay.
Okay?
Yeah.
So here we started with this one, encryption, and then we have the cryptography, and then we have substitute, cipher, we talk about it, cipher, alphabet, and ciphertext. We cover this, okay? The public key system, I explained it already. And then here we have the string number conversion. You know that already, right? Float, int, string, okay. And then date conversion. Date conversion, we actually get a date of a month, date, year format. And then split it by a slash. So you will actually get the month string, date string, and year string. And then you actually get the month string converted to integer -1. You will get the month string, real month string to print now. And then your day plus. So this one is a simple conversion of the date to a string and print that now. Okay? And this one similar. I think it's easy. Format. When you print out, there's a format you can put the index for location. And then actually you have a specifier. For that location, you actually specify the width, precision, and type. Okay, this is similar to what we have so far. So basically, you can do digit, integer format, and then octal, Unicode, hexadecimal, 14-point number, something like that. So this one's okay. So here I have a change. You can print out the location-dependent string format with the specification like that. And then the next one is file processing. We can open the file for read-write mode. So the first string is the name of the file. Second string is the read-write mode. And when you finish the file, you should close it. Okay, and then you can read in the whole file into a string that's called read function without putting 1 or 2 or something there. If you just read in line by line, you read line without S. If you read the whole file into single string, you say read line with S. Okay? And then you can print out some of the string to a file, but I don't do this. I use the write function, your file.write function, similar to this print out to file, okay? And then there's a user file, okay, that's similar to what we have to write them out, okay? So this chapter, the homework is 237A, okay? See you.
Okay, thank you.
Bye.
Bye.